June 22nd, 1943, 26,000 feet above Bremen, Germany. The first burst of flak blooms off the left wing like a black flower, silent at first, then followed by a violent thump that rattles through the aluminum skin of the aircraft. Inside the B-17, the noise is not one sound, but many. Tearing metal, shattering plexiglass, the cough of an engine misfiring, and men shouting into oxygen masks that freeze their words into fog. Staff Sergeant Jack O'Hara, waist gunner, does not see the shell hit the fuel tank. He feels it. A deep, hollow punch beneath his boots, followed by a sudden rush of gasoline fumes that claw at the back of his throat. Everyone aboard knows what that smell usually means. Fire. In 1940, it would have meant death in seconds. O'Hara swings his head toward the wing root, expecting to see flames crawling backwards, igniting the slipstream like a torch. He has seen it before, in training films, in stories from British crews, in the wreckage of burned-out aircraft scattered across English airfields. But nothing ignites. The smell fades. The engine sputters, then steadies. The B-17 keeps flying. Up front, Captain Robert Hayes, aircraft commander, grips the control yoke harder than he realizes. His co-pilot is shouting something, probably about Engine 3 losing pressure, but Hayes's eyes are locked forward, scanning the bomber stream ahead. Dozens of flying fortresses fill the sky, their silver fuselages reflecting the sun like a moving city. Below them, Bremen waits. German flak batteries adjust their aim. Fighters are already climbing. And this airplane, this specific airplane, has just survived something that should have turned it into a fireball. Not because of luck, because of a choice made years earlier in an American design office, far from any battlefield. 3 years before this moment, in 1939, American aircraft engineers were wrestling with a brutal truth that air combat had already proven in Spain and China. Most planes didn't fail because they were shot down. They failed because they burned. Fuel tanks were the Achilles heel of aviation. A single bullet could puncture a tank, spray gasoline into the fuselage, and ignite instantly. Crews rarely had time to bail out. Aircraft didn't fall, they exploded. European designers accepted this risk as unavoidable. Adding protection meant adding weight, and weight meant lost speed, lost range, lost performance. In a war where faster often meant survival, protection was considered a luxury. But American designers, particularly those working on long-range bombers, were thinking differently. If the United States went to war, its aircraft wouldn't be flying over nearby borders. They would be flying hours over open ocean, deep into enemy territory with no friendly airfields below. A burning plane over France was tragedy. A burning plane over the North Sea was a death sentence. So engineers at Boeing, Consolidated, and the U.S. Army Air Corps asked a question most others didn't. What if the airplane could take the hit and keep flying? The answer began with something deceptively simple: self-sealing fuel tanks. Instead of bare aluminum containers, American designers wrapped fuel tanks in layers of rubberized material. When a bullet pierced the tank, gasoline would leak out, but the fuel itself caused the rubber to swell, sealing the hole from the inside. No spark, no flame. It wasn't elegant, it wasn't light, it wasn't fast, but it worked. And it worked again and again and again. By the time Jack O'Hara smells gasoline at 26,000 feet over Bremen, that technology has already saved hundreds of crews he will never meet. The flak intensifies. A shell bursts just off the nose, peppering the cockpit with fragments. Plexiglass crazes but doesn't shatter. The bombardier curses as he wipes blood from his forehead, cut from flying debris, not from fire. Another hit. This one tears through the fuselage near the radio compartment. Shrapnel slices wiring looms, rips into oxygen lines, and punches out through the opposite side of the aircraft. The B-17 lurches. Inside, chaos threatens to overwhelm discipline. But the plane does not break apart, because American designers made another choice. They assumed things would fail, and they planned for it. The B-17 Flying Fortress is not one machine, it is many machines layered together. 2 hydraulic systems instead of 1, multiple electrical circuits, backup controls routed through different sections of the fuselage, engines spaced far enough apart that one explosion doesn't automatically destroy the others. When flak severs a line, something else takes over. When one system dies, another limps on. It's not graceful, it's not efficient, but it keeps men alive. German pilots would later complain that American bombers were impossible to finish off, that they absorbed punishment no aircraft should survive. What those pilots didn't see were the decisions hidden beneath the aluminum skin. The weight penalties, the speed sacrifices, the conscious choice to value crew survival over perfect performance. Back over Bremen, fighters arrive. Messerschmitt Bf-110 slash through the bomber stream, cannons flashing. Tracers stitch across wings and fuselages. One B-17 ahead of Hayes takes a hit to the cockpit and immediately drops out of formation, trailing smoke. O'Hara tracks a fighter with his twin .50 calibers, firing short bursts. He feels the vibration travel through his bones. A round smashes into the fuselage near his position. Metal fragments punch through his jacket but stop short of flesh, caught by armor plating bolted behind his gun position. Another unglamorous choice. Steel where aluminum would have been lighter, protection where speed would have been higher. O'Hara doesn't know it in this moment. He only knows he's still standing. The bomber staggers, wounded but airborne, pressing toward the target. And as the bombs finally fall away, steel doors yawning open, payload dropping toward the city below, the truth becomes clear. This aircraft was never designed to be untouchable. It was designed to be survivable. And that single philosophy will quietly change the air war forever. The bombs are gone now. 12,000 pounds of steel and high explosive fall away from the B-17's belly, and for a brief moment, the aircraft feels lighter, almost eager, as if it wants to climb away from Germany as fast as possible. Captain Hayes banks gently, easing the bomber back into formation as flak continues to burst around them like angry thunderheads. But the danger isn't over. It never is. For German fighter pilots, the most lethal moment comes after the bombs are dropped. A bomber turning for home is predictable, damaged, slower, separated from the tight discipline of the inbound run. And today, several B-17s won't make it back. Hayes knows this. Every man aboard does. What they don't know, what no one in the formation can see from the outside, is how close this particular aircraft has already come to death and how much punishment it can still absorb. Inside the fuselage, Technical Sergeant Frank Miller, flight engineer and top turret gunner, scans the instrument panel. Engine 3 is bleeding oil. Engine 2 is running hot. Electrical gauges flicker where shrapnel is torn through wiring bundles. In another bomber, lighter, faster, built for elegance rather than endurance, this would be the beginning of the end. Here, it's a checklist. Miller reaches for a switch and reroutes power to a secondary circuit. The light's steady. Oxygen pressure stabilizes. The intercom crackles back to life. "Engine 3's wounded, but she'll hold," he says into his mask. This is exactly what the designers expected. They assumed engines would be hit. They assumed wires would be cut. They assumed hydraulics would fail at the worst possible moment. So they gave the crew options. The weight of those options is enormous. By 1943, American bombers are heavier than their European counterparts by thousands of pounds. Every self-sealing tank, every armored panel, every redundant cable adds mass. Mass steals speed. Mass demands larger wings. Larger wings demand stronger structures. It becomes a cycle, one that critics inside and outside the U.S. military question constantly. British planners flying lighter bombers at night openly doubt the American approach. They believe daylight bombing is suicidal. that no amount of armor can protect an aircraft flying straight and level through flak and fighters. The Germans believe it too, which is why Luftwaffe tactics are built around destruction, not disruption. They don't aim to scare bombers away, they aim to annihilate them. A formation of Focke-Wulf FW-19s dives in from above, cannons blazing. One passes so close to the B-17 that Hayes sees the pilot's goggles through the canopy. Rounds slam into the right wing. The aircraft shudders violently. Fuel pressure drops again. This time, the smell returns, sharp, unmistakable. O'Hara freezes, waiting for fire. It doesn't come. Instead, the tank seals itself once more, rubber swelling around the wound like living tissue. The leak slows, then stops. The wing is torn open, metal curled back like peeled skin, but it isn't burning. German pilots notice this. They fire and fire and fire again, watching bullets punch holes that should ignite, should explode, should tear the bomber apart. But the fortresses keep coming. Later in the war, captured Luftwaffe aces will speak with frustration, even disbelief. They will describe American bombers that flew on with engines destroyed, tails half missing, crews wounded or dead, aircraft that by every rule of aviation should have fallen from the sky. What they never see are the test reports, the lab results, the design meetings where engineers argue over whether a bomber can afford another layer of protection, another system backup. They never hear the quiet American assumption that losing a plane is bad, but losing a trained crew is worse. The bomber stream thins as they cross the coast. Below them, gray water stretches towards the horizon. Somewhere ahead, England waits. But the fighters are not finished. One last attack comes head-on, a classic German tactic. Closing speeds exceed 600 miles per hour. There is no time to dodge. The nose gunner fires, tracers streaking past the enemy aircraft. A cannon shell explodes just beneath the cockpit. The blast punches upward, shredding the nose compartment. The bombardier is thrown backward, unconscious. Shrapnel tears through the instrument panel. Hayes feels the controls slacken in his hands. For a terrifying second, the B-17 pitches nose down. Then, resistance. Backup control cables, routed through a different section of the fuselage, take the load. The bomber responds sluggishly, wounded but responsive. Hayes pulls gently, coaxing the aircraft back into level flight. Behind him, men shout. In front of him, sky. This is the true miracle of American bomber design. Not invincibility, not elegance, but grace under failure. The ability to keep flying when everything that should work doesn't. As the coastline of England finally appears, the crew begins to believe they might live. They don't cheer. They don't relax. They've seen too many aircraft fall at the last moment. But something fundamental has changed, not just for them, but for the war itself. Because every crew that survives will fly again. Every lesson learned will be passed on, and every bomber that limps home, torn and bleeding but intact, proves the same quiet truth. The Flying Fortress was never about power. It was about endurance. The English coast grows larger beneath the nose of the bomber, white cliffs cutting through gray cloud like a promise. But the crew does not relax, not yet. They've learned the hard way that aircraft don't wait for permission to fail. Inside the fuselage, the damage is becoming more visible with every passing minute. Blood has dried dark on the bombardier's jacket. The radio compartment smells of burned insulation. Spent shell casings slide across the floor with each vibration of the engines. And still, the B-17 flies. At the fighter bases scattered across northern Germany, pilots are already reporting in. They describe bombers that absorbed impossible punishment, engines destroyed that somehow kept turning, fuel tanks that refused to ignite, crews that should have died, yet didn't. German commanders listen carefully. Then they adapt. By mid-1943, the Luftwaffe changes its approach. If the Americans have built aircraft that won't burn easily, then burning them is no longer the priority. Instead, German engineers focus on destruction by force. Heavier cannon, armor-piercing rounds, explosive shells designed to tear through structure rather than ignite fuel. The 20mm cannon gives way to the 30mm Mk-108, slow, heavy, devastating. One hit can shear off a wing or rip apart a fuselage. Fighter pilots are instructed to aim not for tanks, but for cockpits, to kill the crew rather than the machine. Even the shape of attacks changes. Head-on passes increase, exploiting the one direction where armor is thinnest and reaction time is shortest. The flying fortress has forced the enemy to escalate. Back in England, mechanics swarm returning bombers. Hayes's aircraft rolls to a stop on the runway, tires screeching, one brake barely responding. Engines wind down unevenly. Silence floods in, broken only by the ticking of cooling metal. Ground crew stare. The right wing is shredded. Holes pepper the fuselage like a sieve. The nose looks as though it's been attacked with a sledgehammer. And yet, every man is out alive. Medics rush forward. The bombardier is carried away. Others are treated where they stand, still shaking from adrenaline and cold. An intelligence officer photographs the damage. These photos will travel far, from airfields to design offices, from briefings to factory floors. Each hole tells a story. Each surviving aircraft becomes data. American engineers study those photographs obsessively. They notice patterns, where armor saved lives, where systems failed anyway, where protection existed and where it didn't. And then they change things. More armor behind pilot seats, improved gun positions, better placement of oxygen lines, refined routing of control cables. The design of American aircraft is not static. It evolves under fire. By late 1943, the concept of survivability spreads beyond bombers. Fighters like the P-47 Thunderbolt adopt similar philosophies. Massive engines, heavy armor, self-sealing tanks. They are not the lightest, they are not the prettiest, but pilots walk away from crashes that would have killed them in other aircraft. They fly again and again. This is something Germany cannot match, not because of intelligence, not because of courage, but because of resources and priorities. German aircraft are optimized for performance, speed, climb, firepower. American aircraft are optimized for bringing men home. As the air war grinds on, the consequences compound. Veteran American crews grow more experienced, tactics improve, coordination tightens. German losses, meanwhile, are permanent. A pilot killed is not easily replaced. A crew lost takes months, sometimes years of training with it. The flying fortress does not just protect men in the air, it protects institutional knowledge, and that may be its most decisive feature of all. On the ground, cities burn. In the air, the balance shifts slowly, relentlessly. By early 1944, the Luftwaffe is bleeding itself dry trying to stop aircraft that refuse to die. And all of it traces back to the same unglamorous decisions. Rubber-lined fuel tanks, steel plates behind seats, backup systems that add weight and steal speed, design choices that no one would celebrate in peacetime, design choices that decide a war.
February 20th, 1944, above Leipzig, Germany. The sky is crowded in a way it never has been before. Hundreds of American aircraft fill every altitude, bombers stacked in tight boxes, fighters weaving above and below them like guard dogs. The air vibrates with engine noise, a continuous mechanical thunder that rolls across the continent. This is Big Week, the largest sustained air offensive in history, and it is only possible because thousands of aircrew know that their aircraft will give them a chance to survive. Lieutenant Edward Klein, a B-24 pilot flying his second tour, tightens his formation as flak bursts around him. He has lost friends. He has seen bombers disintegrate in midair. But he has also seen something else. Planes come back. Planes that should not. B-24s with wings twisted out of shape. B-17s missing entire sections of tail. Crews crawling out alive, shaken but breathing. That knowledge changes everything. Men who believe they might live fly differently than men who expect to die. This is the quiet advantage American aircraft provide. Not just metal and rubber, confidence. Confidence keeps formations tight. Confidence keeps bombers on course under fire. Confidence keeps gunners firing instead of flinching. German commanders notice it. Intercepts report that American bombers no longer scatter as easily, that escort fighters remain aggressive even after taking damage, that bomber streams push through flak belts instead of turning back. The fortress mentality has become psychological as much as physical. The enemy adapts again. Rocket-firing fighters, air-to-air bombs, ramming attacks. Desperation bleeds into doctrine. But the math no longer favors Germany. Every American aircraft lost is replaced, quickly. Every crew saved flies again. Every crew killed leaves a hole Germany cannot fill. Back in the United States, factories run night and day. Wichita, Seattle, San Diego. Workers, many of them women, many of them new to industry, build aircraft that already incorporate lessons learned over Europe. Survivability features are no longer optional, they are standard. The flying fortress idea spreads to transport aircraft, naval planes, even trainers. Live through mistakes, survive damage, protect the human inside the machine. It becomes an American design philosophy. By June 1944, Allied aircraft dominate the skies over Normandy. German fighters appear in smaller numbers, often briefly, before vanishing again. Fuel shortages, pilot shortages, aircraft shortages, all compounded by years of fighting aircraft that refuse to burn. On D-Day itself, thousands of Allied aircraft operate with near impunity. The fortress has done its job. Years later, veterans will struggle to explain why they survived when so many did not. Some will talk about luck, some will talk about God. Few will talk about rubber fuel tanks and steel plates. But history remembers. The American decision to trade speed for survival, to build aircraft that could be hurt without being killed, reshaped air warfare forever. Modern combat aircraft still follow the same logic: redundancy, armor, damage tolerance, not because it looks impressive, but because it works. The B-17 that limped home over Bremen in 1943 is long gone now, scrapped, melted down, forgotten. But the idea it carried into the sky remains, that an aircraft does not need to be perfect. It only needs to give its crew a chance.